Hello everyone. In this video, we will be discussing about the details of Ansys academic program and the career opportunities that can be expected for an undergraduate student or a postgraduate student in mechanical engineering related with the computational flow dynamics. So first of all, a brief about the Ansys. It's basically used for both the design and the analysis purpose, and it finds applications in the field of mechanical, civil, electrical, and electronic fields. And it's quite easy for learning the simulation using Ansys because it's having a graphical user interface. And lot of updations are available for Ansys, and there are a lot of packages that keeps it widely accepted in industry as well as the research fields. And while focusing on mechanical engineering, we have specific applications in the field of structural analysis, where we will be able to analyze the deformation, stress analysis, vibration analysis, impact analysis, etc. And in the field of fluid flow problems that's related to incompressible flow, compressible flow, multi-phase flow, etc. and related to coupling of different physical problems, that's multi-physics can also be used in ANSYS simulations. And we can use Ansys packages for thermal analysis also, where we will be dealing with the heat transfer cases. And there's a specific package for IC engine called IC Engine Fort in Ansys higher versions. And we have special packages for reacting flows as well as the combustion. And there is another package for turbo machinery also. So in mechanical engineering case, there are a lot of packages available for simulation. So how it's applicable for a student perspective? We'll be studying all these things in our BTech curriculum. We'll be knowing all the physics, or we will be having a strong theoretical background. And the answers can be used to simulate what we have studied. So this will underline our theoretical background, and we will be able to know the things by visualizing through the simulations. So it's a very good practice to learn ANSYS or similar softwares while you're doing your undergraduate course, so that you'll be you'll find it easy for yourself to understand the physics in a much better way. And we can categorize the CFD courses into three. One is the basic course. Most probably we will be able to study the ANSYS from the third year or the fourth year of our undergraduate program. And during this basic course, it's better to use a software that's having graphical user interface and study in a broader way that all the packages that's associated with that particular software that's confined in our area. And later, a little bit advanced, we can focus on few of the solvers. So Ansys is one such a software that's having graphical user interface, and you can start studying Ansys as a basic program in CFD. Later on, you can focus on some of the solvers in Ansys so that you can become an expert in that particular area, and you can study the physics of those problems in a detailed manner so that you can gradually become an expert in that particular field. And in the case of an intermediate program, we need to study two softwares. One is MATLAB. You can study the basic programming using MATLAB. And the other one is OpenFOAM. It doesn't have a graphical user interface. So more or less it's like programming. There's a little bit programming in that. So you will be studying much more detail rather than Ansys or a software that's having graphical user interface, because a lot of things that we need to give as input. So we need to know a lot of things for doing simulations using the softwares like OpenFOAM. So it can be treated as an intermediate level course. And in that particular course also you can become an expert in few of the solvers that's present in OpenFOAM. And as an expert, you can do computational fluid dynamics or finite volume method or finite difference method or find elemental analysis. What all kinds of numerical problems that is used in all the simulations, irrespective of CFD analysis. You can do all these simulations by creating programs by your own. So programming using C++ is an expert level program. Then again, a question arises that we are mechanical engineers and now we are talking about a C++ program, and then that too is an expert level course in CFD. While coding using C++, we need a much stronger background knowledge about the physics as well as the mathematics. Mainly we will be dealing with partial differential equations in the case of computational fluid flow. The main equations that will be used is Navier-Stokes equation, moment equation or continuity equation, energy equation, etc. So all these things needs to be coded, so that we need some mathematical background for solving these equations. Then we need to know some theory or the physics behind the problems that we are going to code. So much stronger basic knowledge on the physics as well as the mathematical background is required. So it's a more important or the core job of a mechanical engineer rather than like a programmer based on the computer science. Now, coming upon the skills required. For studying CFD, from the basics onwards, we need to know some of the mathematical background as well as the physics of the problems that we are doing. And for the higher end, we need some programming skills also. So if you are talking about the basics of the CFD programs and the skills that just we are correlating that, we can tell that some of the physics problems that we might have studied in our BTech curriculum is some compressed flow or incompressed flow problems. In such problems, we'll be coming across with some of the equations, mostly that will be partial differential equations. And we need to know some numerical methods for solving these partial differential equations. So that's some basic mathematical background that we require. And about the physics, what all equations are being used and what's the condition, or what is the cause, or what forms, or what all equations can be used to formulate that particular physical state. So all those things that we need to know. So that's about the theoretical background that we need to acquire while doing the CFD problems. Now, while looking on the career opportunities that we have, one is freelancer. We can work as a freelancer. There are a lot of opportunities that's awaiting for us to work as freelancers, because there are a lot of projects will be there available online. We can bid that projects and we can do that by our own. The second one is associating with some startups or small companies. You can use your LinkedIn profile for searching for such job opportunities. And mostly all these companies will be focused on some of some domains only, not in a broader way. So that we need to be specific on that also, because no one can be an expert in a broader manner. So first of all, we need to focus on some of the solvers that's available in CFD softwares, or some of the physical problems that we need to be an expert on. And then look for the companies that is doing or taking the projects similar to what we know. So that's about the startups or the small companies. And while coming to the industries, there are a lot big opportunities that is awaiting for us in the industries. We can become an aerodynamic analyst in an automotive industry, or an HVAC analyst, or a simulator, or an engineer in an HVAC related industry. So likewise, there are a lot of opportunities that is awaiting in other industries for a CFD engineer. Now, if you are an expert, you know the programming based on this computational fluid dynamics, and you have a strong mathematical background and a theoretical background on the physics of the problems. You will find your job opportunities in core industries like Altair, Ansys, etc., who are developing these kind of analysis softwares. And the other opportunities that's awaiting for us is in the field of research. So this is a brief about the career opportunities that is awaiting for a mechanical engineer who wish to work in the field of computational fluid dynamics. And in some cases, in some industries, they will prefer only the postgraduates. And in some cases, they will be taking undergraduates also. But it will be purely based on the project works that we have done in our curriculum. So while doing the project works, we need to be focused on our career goal. So that much importance that we need to give on our projects, and that speaks a lot while we are looking for a career in computational fluid dynamics. And this just based about our company profile, you can connect with us in our Facebook, Instagram, or YouTube. We will be providing regular videos and the tutorials based on these softwares OpenFOAM, MATLAB, and Ansys. Or you can reach us through our website or email or contact directly using phone number. So thank you.